Alright, continuing where we left off. I'll get rid of this because, again, that's excess geometry. And I have my letter, and you could, of course, have an entire stencil of words out there. Just remember that you can't take text as it is and use it. You have to trace around it. And, again, making sure that everything is continuous and, as you can see, closed. Probably still wouldn't be able to cut this because it's a little bit too small. I mean, it's right around a 1/16 of an inch space there. That's a little bit too tight for the plasma cutter to get. But for the most part, we're not going to actually cut this out, so we'll just note that and go on. So I now have all my components are continuous and closed, and they are relatively ready to go. The only thing is, I now have to deal with the issue established with located within the vicinity of the origin. Alright? Again, what that means is, in terms of the coordinate system, or this giant coordinate plane that AutoCAD is, that we have to make sure that our object is zeroed within proximity of that origin. Understanding that even though we're working out in there in this infinite space, every position that our cursor is in a coordinate, an x, y, and z coordinate. So many units in the x, so many units in the y, and so many units in the z. Now, for our case and example, we're only dealing with a 2D type system, so we don't actually add z features to it. Sorry about that. So, we have the grid system of x, y, and z coordinates that we have to remember that AutoCAD exists in. And again, we're not dealing with z because our component really doesn't work with cutting into the z. But there are some machines that do, and you'd have to be a little bit more specific to each individual machine. But for a basic 2D format, we need to actually help the machine to orient itself, or locate its origin. Now with AutoCAD, that would be the coordinate referred to as 0, 0, right here. 0x position, 0y position. Now in AutoCAD, we've never really worried about that too much because we have all this open space. But it is necessary. And just to give you an idea of where the origin is, I'm going to draw a circle. But when the circle command begins, it asks you to give it a center point. Normally you just click. Instead of clicking, I'm just going to type in 0, 0 and hit enter. And we zoom back a little bit and we see that it has placed the circle at the dead center of what we call the origin. That's why you see the y and the x going from here to here. So I'll just make this a diameter of 2, and there it is. That circle now represents the origin of this coordinate system. I will use my move command to go ahead and get my smiley face closer to that point. And there we go. So now I have it in proximity. But we might as well get a little bit more specific. I like to use circles to locate the origin because it gives me something to lock onto when I need to draw something else. Specifically, the type of material you're going to cut this out of. The concept is that you're going to have a sheet of metal or some type of material, whether you're using a CNC with wood or whatever, you're going to have a sheet or material to use as your cutting material. So it's basically going to cut the smiley face out of it. So with that in mind, you need to have an idea of what size material you're going to use. Is it a plate of steel perhaps that is 2 foot wide by 3 foot wide, or 12 inches wide by 7 inches wide? Having an idea of what you're going to use to cut from is a good thing. So let's just say for argument's sake that our smiley face will be cut from a sheet of steel that is 12 inches long and 8 inches tall. Okay, let's see if that actually will work with what I've done here. Just barely, which is a good example. Now another thing to note is which orientation will the cutter or the device want the material in. Notice I keep moving my face around, just kind of give me space. I'll go ahead and rotate this just because I know that we like to use our plasma cutter running in the long direction. And I'm going to locate the sheet of material at the origin. I'm just going to use that circle I created to locate it there. Now with that in mind, this is my sheet of material. This helps me locate my origin, and if I were to zoom in, I know that the corner of my material, my plate, is at 0, 0. Which means that when the plasma cutter comes in and hones itself, it's going to hone itself right on this point. Or it's going to assume this point is the 0.0 location. Now I'll just move my smiley face over into position, get it there, and, since I can't fit more than one smiley face in here, we'll just cut out one smiley face. Another thing I might as well do is go ahead and delete my circle, because again, you can't have, remember, excess geometry. So anything that's not going to be used in the cut needs to go, including my little outline of my plate here. Another important thing to remember is that when you actually set up these files, you do not want to have a lot of layers. In fact, as you can see here, I only have one. Now sometimes you will have a default of 0 and the default layers that come with it, and that's okay. It's just the fact that the more stuff you have associated with the file, the more complex and more things you have to do with the plasma cutter. So I like only having one layer to work with. So I've got my smiley face. I've got it located, I got my sheet located within the origin, I've got my smiley face located within the sheet I want to cut, and to not waste a lot of material, I'm going to move my smiley face down closer to the edge. Now typically, we like to leave a space of about a quarter to a half inch, we'll say 375 in this case, from the edge of the material, just to make sure that in case they didn't get it perfectly square or something like that. So actually in this case I'll just do 0.25 because it is kind of a small sheet. I'll just draw a line here to help me locate the smiley face in proximity to that. There we go, looks good. I'll delete that line off. Now I won't waste a lot of material, so when it's done cutting we'll at least still have all this left over. In fact, I probably want to move it a little bit more this way because it's again still using up a lot of excess material, which is not something we want to do. We want to save as much as we can for other projects. So there's my smiley face. It's inside my plate that's going to cut. Now, just so you know, if I were to send the file like this, the plasma device would actually try to cut the outside of the plate, which it doesn't need to, because this line's still here. So I need to delete it too. Alright. So now the file's ready to go. The smiley face is continuous and closed. It is located within the proper proximity to the 0, 0 coordinate. The only thing, and we have deleted off the excess geometry. The only thing we have to do now is convert it to a DXF file format, which is probably the easiest of the whole procedure. All you do is go to your big A and go to Save As, AutoCAD Drawing, and when it pops up for your Save As option, here's what you do. Select wherever you want it to go. Could be the desktop screen, could be your My Documents, wherever that may be. But name your file. Let's just say Smiley CNC. And it's usually helpful to actually give the size of material you're cutting from. We said it was like, what, heck, I don't remember what it was. It was probably 12 by 8 or something like that. If you actually give the size of the plate that you're going to cut from in the name of your file, it helps the operator to know what size of sheet to lay down on there. Since you can't add any information in here in the file without the CNC freaking out, you can use the file name to do that. You don't have to do that. You can name it whatever you want to, but this is just a tip. And let's say we're cutting it out of a 3/16. Alright, so Smiley CNC 12 by 8 by 3/16 lets them know what plate size to use, and the most important thing here is this type of file. You see this right here? This is what you change from what's typically set to all the way down to you see a 2000 LT 2000 DXF. You probably can't see it on the screen because it's going down below, but we are choosing the option at the bottom that says DXF, and I like to use the oldest form possible, but that way there's less compatibility issues. So AutoCAD 2000 / LT 2000 DXF is the key. And let's see here, that looks good, everything looks good. I'll just go ahead and hit save. And that's it. The file is now created, add on the screen. Can't really show it to you, it's just a little file folder that's located to add on the desktop screen, but it's out there. You can probably see it here for, no, you can't even see it for a second. Anyway, it's out there, and all you have to do is transfer that to your instructor or whatever system may put it on a flash drive so you can plug it into the CNC system. But you've met all the requirements. It's in DXF format. It's located in the vicinity of the origin. Again, that is the coordinate of 0, 0, which is established easily to do just by drawing a circle. And when it asks for a center point, just type in 0, 0, enter, and it automatically locates it at the center of the origin, and then you can just specify its diameter size just so you can lock onto it and know where it is. So we've got that done. We've deleted off the excess geometry, everything we've done is closed loop, and everything is continuous. So we have a viable CNC cutting file, and what happens next is this file is transferred to the device, and it interprets our geometry and sets up its cutting path for its own procedure. Now the fact is, you can't get good at this until you practice it a little bit. So it's important that you do some experiments, see what you can create. We often use it for all kinds of realistic parts. When we have multiple cuts, if we have a big sheet, we like to do multiple versions of something. Nothing wrong with using your copy command and creating multiples. Many times what we'll do is we'll rotate and twist and turn and do whatever we need to make it use up the least amount of space. For example, I might stick it right in here so that I can cut out another one and not waste this spot here. So that's basically the procedure, and that's how it works every time. A lot of times people forget to clear off the excess geometry, and that gives them problems. So that's one of the first things you check for. Another thing is they forget to locate near the origin, which is another important thing to check for. Closed loop, continuous, that's pretty easy to check real quickly. Just make sure there's not excess geometry underneath after you've done your boundary command. That's why I moved it over, as you saw earlier. I moved it over. And again, I'll demonstrate just to make sure you're clear on that. After you create something and you're ready to boundary it, you just type in boundary, hit enter, select inside, hit enter. Then you click on each individual component, one selection, not a box selection, and you use your move command to move it away from itself, and you can delete off the excess geometry. That way you're guaranteed to only get what you actually needed to cut, and there's nothing hidden underneath. So there's your procedure. Trial and error trial efforts on your part to make it happen, to keep doing it and do it till you get better at it is all part of it. So if you have any questions, let me know, but that's a brief overview, and hopefully that'll get you what you need. All right, well, good luck and happy CNCing.